Assalamualaikum everyone. So in this video we are going to discuss about the past paper of 2025 May June variant 11. Okay, so let's start with the first question without wasting any time. In the first question, which quantity is a vector quantity? It's pretty easy question. We know vector quantity is the quantity that have direction. Okay, so quantity with magnitude, obviously all the physical quantities have magnitude plus direction, that will be called as physical quantities. Pressure will not have the direction, temperature is scalar, weight is the vector quantity, and this will not also have the direction. So it's option C we have. Okay, and the next question, four students ABC have completed an experiment to determine the acceleration of the free fall G. Each student repeated the experiment, and we have the different values. They have done the same experiment 3 times. So this is the value for the experiment 1, experiment 2, experiment 3, and we have these different values. We have to tell low precision and high accuracy. Okay, so what we need to know first, what is low precision? The low precision value is, that should be values should, sorry, it's not low, it's high precision. Okay, high precision values should be close to each other. First condition. And the second condition we have is low accuracy. Low accuracy is values should be away from true value, and we know true value for G is 9.81. okay, so we have to look at the options. Away from 9.8, so this will not be the option, this will not be the option, this is also close to 9.8. somehow these values are very away from 9.8, and if we see, they are close to each other, so they should be close, high precision, low accuracy. Okay, so it's option D we have. Okay, in the next question, our diameter of a ball is measured, and what is the absolute uncertainty in the volume? First you need to know the formula for the volume. So it's volume of a ball is, what is spherical object, so volume of ball, that is spherical object, it is 4/3 pi r cube. Okay, but we have information in term of diameter, so we know that radius is half of diameter, so you can make this thing as 4/3 pi d/2, and there is a cube on it, so this thing will give you 4/3 pi d cube divided by 2 cube. 2 cube is 8, so ones are and 2, it will give you pi d cube. 2 into 3 is 6. Okay, so this is the basic expression that we have. Okay, let's calculate the volume, because we are going to need this thing later on. Its pi is d, we have this thing, this is the d, and this thing is delta d, right? So d is 5.26, and there is a cube on it, divided by 6, that thing will give you 76.20 centimeter cube. Okay, when you do the calculation, you get this answer for the volume. But what we need uncertainty in the volume, right? We need delta V. So we know fractional uncertainty of V will be equals to 3 times fractional uncertainty of D. Why 3 times? This is called the power factor, because there is a cube on the diameter, So there will come a 3. Whatever the power is on that variable, that power will come here. Okay, so you just have to put it will be fractional uncertainty of v is delta v over v is 3 into delta d over d. What we have to find delta v, so it will be 3 into delta d divided by t into v will be multiplied on the right side. Now just put the values, you will get 3 into delta d is 0.02, d is 5.26, and v we have calculated is 76.2. When you do the calculation, you will get 0.87 centimeter cube. Okay, so be careful with the calculation. The common mistake is this is option B is the right answer. Okay, so most students choose option C because they find the percentage uncertainty instead of fractional uncertainty. Okay, so C is the popular wrong answer. Okay, so you have to be vigilant that you have to find absolute uncertainty, not the percentage uncertainty. Okay, so in the next question 3, what we have, two vectors x and y are shown. What are the directions of x plus y and x minus y? So you have to find the resultant vectors. Okay, so let's first draw the x. There we have x vector and this is the y vector. Okay, so first deal with the x plus y. I'm going to apply the head to tail rule. Okay, head to tail rule. What is the head to tail rule? First consider a vector. X is a first vector, let's suppose, and y is a second vector. So what I'm going to do, I'm going to consider x vector is placed like this, and I have to imagine that I'm going to place the y vector on to the head of the x vector. The tail of the y is exactly on the head of the x. Okay, so how the resultant will be? Resultant will be from the tail of the x till the head of the y. So this is the resultant vector. So these are correct, these are wrong. Now let's look at, this is basically x plus y that we have done. Now we have to find for x minus y. First thing that you need to understand that addition is a special case of subtraction is a special case of addition, right? So you can write this thing as x plus minus y. So this is simply, there are two vectors, one vector is x and one vector is, you can name it minus y. They're going to add with each other by following the same rule. So what is the minus y vector? So if this is, let me take this one, if this is the y vector, if I need minus y vector, what I have to do, minus y, I just have to change the arrow in exactly opposite direction. This is the y. Okay, again I can repeat the same process. I can take x as the first vector and I have to place y in such a way that, minus y in such a way that the tail of the y should be on the head of the x, like this. Now for the resultant vector, resultant will be from the tail of the x till the head of the y. This is the resultant vector here. Okay, so it's option B that is correct. Okay, so this is how we can solve this thing. In the next question, a ball is vertically projected vertically downward with the initial velocity of u. A resistance is negligible. When A resistance is negligible, acceleration is equals to g. We know that. And what is the displacement from its initial position? You have to find s, and you have given the time. As acceleration is constant, we can apply equation of motion, and if you see, we don't have the final velocity. We don't have the final velocity, right? So we have to choose equation of motion in which final velocity is not involved. Okay, so when you think about it, you will know you can use S is equals to ut plus half at square. If you look at the given data, we have all the information that we need to put here. U is 20, T is 1.5 plus 1 by 2, acceleration will be 9.81, and T is 1.5, and there's a square on it. When you do the calculation, you will get 41.03 meter. So that is roughly 41. Okay. In the next question, a surveyor's device emits a pulse of light. The light is reflected from a wall 150 meters away. So let's try to consider the scenario first. Let's suppose there is some device placed and there is a wall. Okay, let me make it a bit closer here. Okay, so this is a wall and a pulse of light is going all the way from the device and coming back to the device after reflecting from the wall. What we have to find? We have to find total time in going towards the wall and coming back for the device to the wall and then back to the device. Okay, so we know we will use the basic relation velocity as speed is equals to distance over time. So time is equals to, I can write total time is equals to total distance covered divided by speed. Okay, so total time is, if you see the total distance covered, the light is going all the way from here to here, it's covering 150 and then coming back again 150. So this is the total time, the total distance covered, that is 150 plus 150 divided by the speed. Okay, so what is the speed of the light? That is 3 into 10 is power 8. Let's do the calculation. Okay, just give me a second, let me. Okay, so it will be, when we do the calculation, we will get 1 into 10 is to power minus 6. You can write it as 1 microsecond. 10 power minus 6 is micro. Okay, so it's option D we got. Okay, and the next question, which equation of uniformly accelerated motion can be derived using only the gradient of the velocity time graph? So if you remember the velocity time graph, there is a velocity, there is a time, the gradient is rise over run. Rise is change in velocity divided by the time, and this gradient, if you remember, that thing is equals to acceleration delta v over t. It can be written as a is v minus u divided by t, and it can be written as v is equals to u plus at. Okay, so it's option C we have. Okay, in the next question, an object is projected horizontally from a table at time is 0. The object falls in a uniform gravitational field. A resistance is neglected, so acceleration is equals to g. You have to tell which graph is representing the horizontal and vertical components of the velocity. So this is from the projectile motion and this is horizontal projectile. Let's suppose this is the surface. I can suppose this thing as a, let's call this a table from where you are throwing that thing, and this is the object. So this object is projected like this. It will move horizontally at the start and eventually keep on moving like this, and it will hit the ground. So what we know in projectile motion, as there is no other force than the gravity, there is no acceleration in the horizontal direction, right? So we know Vx is equals to Ux will remain constant. There is no acceleration in the horizontal direction, so there is no change in the horizontal component of the velocity. So it's pretty easy. Horizontal will be this thing, it's not changing, so this is Vx. We have to look at the Vy. If you see at the start, the object is moving like this, it's totally in the x-axis, there is no vertical component, so we can say at start Uy is equals to 0. So vertical component is starting from the 0, and if you see, this projectile is gradually moving down and down and down, the gravity is pulling it towards the ground, so it will keep on gaining the vertical component. So at this point its vertical component is maximum, you can say. So vertical component will increase all the way, right? So, and how it is increasing, is it increasing linearly or non-linearly? It will increase linearly. Why? Because you know A is equals to G, that is constant, that is a vertical acceleration, right? So acceleration is constant, so the slope is determined by the acceleration, so slope is constant, slope will be constant, right, because of the acceleration, and it should be increasing starting from the 0, and this is the Vy. Okay, so the right option we have is Q and P, that is option A. And the next question, what is always conserved in elastic plane? Okay. Now this is from the energy conservation, elastic and elastic plane. You know, in elastic plane, momentum remain conserved. Okay, in all the cases, kinetic energy remain conserved in all the cases. There was another thing that they are trying to confuse you with, that speed of approach it's a relative speed of approach will be equals to relative speed of separation, but we know speed is not equals to velocity. There are two different things, right? So the common wrong answer that students choose is the option A. They mostly choose this one because they confuse this velocity with the speed. Okay, so there is no law like this that the velocity will remain conserved. No, the thing that we have studied, that is the speed of approaching will be equals to speed of separation. So velocities will not remain conserved, they will change because they are changing the direction basically after the collision. Kinetic energy, yes, it will remain conserved, so it's option B you have. Okay, A is the most popular wrong answer, and I have told you there why a student think like this. Okay, again question 10, this is from the third law of Newton, and mostly students struggle with this concept. Okay, what you need to keep in mind that the action and direction forces act on two different objects. Okay, so in this case the most popular wrong answers are B and D. Mostly students choose B and D because candidates are not appreciating the fact that the third law always apply on the two different objects. If object A is applying a force on B, the B will apply a force on A. Action is on if A, the reaction will be on object B. It will not be on the same object. Okay, so if you see in the first case, A resistance and force on gases, it's not making the pair. Okay, so A resistance is between the rocket and the air, and the force on the gas is rocket and the gas. It's more or less same thing, right? So, or another thing, in the third law, the third object will not be involved. If you consider the gas as a different thing, then there are three objects: air, rocket and gas in the first case. That is not the option. Okay, there should be only two objects, those are involved in Newton's third law: air resistance and thrust. Air resistance is acting on the rocket, right, and thrust is also acting on the rocket, so there is only one object. That is also wrong. Force on gases and thrust, more or less same mistake or no? Yes, it is force on gases and the thrust. So if you consider this rocket is applying a force on the gases, good, and the gases in return applying a force on the rocket. So action is on the gas, reaction is on the rocket, thrust is on the rocket, right? Force on rocket, and this is force on gases. So this is action, reaction, perfect pair. So option C is correct. Why D is not correct? Thrust and the weight. You know, thrust is between the gas and the rocket, and weight is between the earth and the rocket. So there are three objects involved in this option: rocket, gas and the earth. So this will not be the option. Okay. In the next question, two blocks K and L slide together on each other along the horizontal frictionless surface. Diagram is showing you the different data before the collision. During the collision, blocks are in contact with each other for a time of this. Okay, so you have the contact time as well. After collision, the blocks separate and L move back along with the original path with the momentum of this. So you have momentum of L. Okay. So what is the magnitude of the average force exerted on block L by the block K during the collision? Okay, so how we have to do this thing? We have to find, we know force is change of momentum per unit time. Okay, so as we have to find force on block L, what we have to do? We have to find change in momentum of L. Okay, so change in momentum of L is final momentum minus initial momentum divided by the T. This is the final momentum of the block L. Okay, so this is 0.12 minus initial momentum is there, it is, okay, if you see, if this thing is moving in this direction initially, after collision it will move rightward. So I'm taking rightward direction positive, so this will be taken as negative. Okay, so this is negative 0.46. Momentum is a vector quantity, so you have to consider the directions. Okay, so how we know that the direction? Because they have told us in the question that after move backward in the opposite direction. Okay, so if you're taking rightward direction positive, the leftward will be negative, obviously. So 0.46 and divided by the time is 0.084, and when we do the calculation we get, let me do it, it is 0.12 plus 0.46, because minus will add up, that will give us 0.58 divided by 0.084, that will give us 6.9. Option C. Okay, in this question the most popular wrong answers are B and D. Both have the different reasons. Okay, so if you neglect this thing, if you neglect this sign, you will get option B. That is the wrong option. Okay, if you neglect the vector thing, and if you are neglecting that thing that you have to find force on L, just consider when you have to find force on L, you have to find change in momentum of L. Okay, only when you consider the change in momentum of both the objects, then you will get the option D, That is also a popular wrong answer. The only correct answer is C, okay, when you do it correctly. So let's move forward. In question 12, we have a flying machine that would work like a screw to lift the pilot into the air, and the screw is rotated by the pilot. Okay, so this is something that will rotate and act like a screw, and this thing is used to lift the pilot. The machine and the pilot together have a mass of 120. Which useful output power must the pilot provide to move vertically upward with a constant speed as given here, 2.5? Pretty easy question. P is equals to F into V. We know that force, how much force you have to apply. If you have to lift something, you have to at least apply the force equal to its weight. So it will be equals to mg, and V, let's put the values. It is 120 into 9.81 into 2.5. Let me do the calculations. It will give me 2943 watt. Okay, so it is nearly 290. We can say it's option D. Okay. In the next question, which row describe a pair of forces that forms a couple? Pretty easy question. Couple is equal forces, opposite direction. Okay, so forces magnitude should be equal, direction should be opposite, so it's option B. Okay. Okay, so in the next question, what we have, a uniform cylinder of weight 25 Newton is suspended from a Newton meter. So what we have its weight. The cylinder is fully submerged into the water. Okay, and the reading on the Newton meter is 10.0. Okay, so if you've seen the question, the weight of the object is 25, but Newton meter is telling you the reading of 10. Why? Because that thing is submerged into the liquid. But you have to keep in mind, Newton meter reading, you can take note of it. Newton meter reading is always, in all the cases, equals to resultant force. Okay, you have to keep that thing in mind. Okay, the water is replaced by liquid with the density of 10% greater than the density of the water. The cylinder remain fully submerged. What is the new reading of the Newton meter? Sorry. So let's try to figure out the first scenario. Initially, what we have, the reading is, let's call this reading FR, resultant force. FR is equals to, and let's call up thrust equals to U. Okay, I'm naming this force, or you can say it's FU. Okay, so what are the forces acting on this thing? The weight is acting downward. Because it is in the water, the upthrust will act upwards. So the Newton meter reading is 10. So it will be weight minus Fu. Both forces are acting in the opposite direction, and weight is greater than the upthrust, right? That is the reason why it is submerged into the liquid. It's not floating on it. So this will be equals to, okay, so we have 10 Newton meter reading, weight is 25 minus Fu. So Fu we get 25 minus 10, that is 15 Newton. So I know this is the upthrust initially. Okay, so let's figure out the next scenario, that after increasing density by 10%. Okay, so what I have to figure out, 10% of Fu is 15 Newton, right? So to find 10%, what I have to do, 10 multiplied by 15 divided by 100, that thing will give me 1.5. okay, so new upthrust will be 15 plus 1.5, that is 16.5. okay, so Newton meter reading is, we know, is equals to FR, resultant force. Now the resultant force will be the weight minus this 16.5. Weight is still 25 and 16.5, that thing will give you 8.5 Newton. okay, it's option A. In the next question, question 15, a student balances a 30 centimeter roller on a fulcrum set at the 15 centimeter. Okay, so this thing, let me write it down there. This reading is 15. Okay, she then places a 50 gram of mass on one side and 20 gram of mass on the other side, and there is something placed here as well. So which mass should be there? You have to find the mass of this thing. Okay, so when you are solving the questions for the moments in these type of scenarios, when things are balanced, the mass and the weights are act in the same way. Okay, so you don't need to convert this thing into the weight. Even you don't have to convert the gram into the kg. You will get the same answer in all the cases. Okay, so let's take them as it is. So we know one movement is produced by there, that will be the clockwise movement. One will be there, that is the anti-clockwise movement, and one is there, that is the anti-clockwise movement. And this thing is balanced, right? So we know from the principle of movement, the clockwise movement should be equals to anti-clockwise movement. So I can write sum of clockwise movement must be equals to sum of anti-clock movement. Okay, so clockwise movement is simply 50 is the mass. I'm taking this mass as the weight and mass, it will not make the difference, so I will take this thing as a force or something. So it is 50, and distance will be from the pivot point till the point of action of force. So it is 15, that is 23, so that will give me 8, right? So that is 15 to 8. Then clockwise is, I'm going to consider this thing 20. So 20 into the distance, this is 11 and this is 15, so this distance is 4, plus I'm going to consider the thing that we have to find, mass m, multiply by distance, this is 7 and this is 15, so from 7 till 15 is 8. okay, so to find m will be equals to 50 into 8 minus 20 into 4 divided by 8. Doing the calculation, you will get 40 grams. Okay, as I haven't converted the masses into the kgs or the weights, so I will get the answer in the grams as well. Okay, so it will be the 40 gram option B. In the next question, question 16, a submarine is at depth of 130 meter below the surface of the sea. The pressure on the submarine due to the sea is P. So first thing, when we know the pressure is rho gh in the liquid, right? So they are telling us when the depth is 30, g will remain g, density remain density, the pressure is P, small p. Okay, this is the information they have given us in the question. The submarine sink to a depth of 260 meters below the surface. Assume that the density of the water remain constant. What is the pressure difference, okay, between the pressure on the submarine due to the seawater at the two depths? Okay, so the new pressure, I can say it's rho g and the depth is 260. Okay, what I have to find change in pressure, that will be the P nu minus the initial P. So if I see, this can be written as rho g 260 minus, okay, this is 130, it's not 30, okay, into rho g 130. When you subtract them, you will get, let's do it here, you will get rho g 130. Okay, and we know that rho g 130 is equals to small p, so I can say change in this thing is equals to p. Okay, so option is C. Okay, the most common mistake, the most popular wrong option is option D. Most students choose 2p. Why? Because they ignore this thing. They're asking about the difference in the pressure, not the final pressure. We know that thing. If the pressure here 130 is P at 260, it's a double the depth, the pressure will be double, right? But they're not asking about how much pressure is there. They're asking about what is the difference in the pressure. Okay, so just have to keep in mind this thing. And the next question, an object is falling in a uniform gravitational field. Which two quantities are sufficient to calculate the change in gravitational potential energy? So first you need to know the relation for the change in GPE gravitational, it's mg h. Okay, what this mg is weight, and what this h is vertical displacement. Okay, so it's option D you have. Okay, so why we need the g as well? Because they haven't told us that it's moving in the on the earth or somewhere. Okay, we don't know the value of g. So if you don't know the value of g already, then what you need the weight and the vertical displacement. Okay, in the question 18, point x, y and z are on a rough horizontal surface. I like to highlight this thing. It's a horizontal surface, because whenever students see this picture, they consider this thing as a height. This is not a height. This x, y, z, they are all on the same height. They are placed on the ground. You have to let this thing sink in. Okay, so you will not make the mistake, because these are the questions mostly when we do, they are giving us this thing as a height, but this is not the case in this question. Okay, this is the most common mistake that students do. A box x is pushed across the surface x to y, so it's moving from x to y, then from y to z. So this is the path of object, what they named it, object P. Okay, so let's color this thing. This is the P. Okay, and the work done against the friction from x to y is 200 joules. Okay, so here the work done is 200 joules. Okay, then an identical box Q is pushed in a straight line from x to z. Okay, so let's call this x to z. This is about Q. Okay, and the magnitude of the frictional force between the boxes and the surface is constant, so it's same everywhere. How much extra work is done against the friction when moving from P to Q? Moving P then Q, sorry, not between P then Q. Okay, so what you have to do, you have to find difference in burden. So what I can say, burden by, it's obvious from the figure that burden by the P will be more, because the forces are same. P is covering the more distance, minus the burden of Q, that you have to find. Okay, so if you have to find total burden of P, it's mean I need burden from x to y, that is given, plus burden from y to z, because that is a path of object P, minus I have to do the burden of object Q from x to z. Okay, so what information we have? We have this thing, this is xy. Okay, and from the word done against the frictional force to move box from x to y is it's 150, it's not 200, it's 150 joules. Okay, then what is 200? 200 is from x y to z. Okay, this work done from there they have given us. Okay, the work done from y to z is 200. Okay, so if I have to find work done from, I can simply put these values here. XY is 150 plus 200. We are sorted with this thing. We have to find this thing. For this thing I need force and I need distance. Which distance? I need xz. Okay, to find force I can use this information. We know work done from xy will be equals to force multiplied by 3, that is a distance, so F will be equals to 150 divided by 3, that is 50. Okay, so we have one thing, this thing is 50. Okay, and I need distance. If I need this thing, this is distance xy, we can use the Pythagoras theorem, but for this thing we need this distance first. Okay, to find this distance we can use this information, that wyz is equals to f into distance, which one, yz, and we know all the forces are same they have given us, so 200 is equals to 50 into d, then d you will get 200 divided by 50, that is equals to 4. So this thing is 4 meter. Okay, if this thing is 4 meter, this is 4, this is 3, this will be, you can use the Pythagoras theorem, so this will be 4 square plus 3 square, that thing will give you 5. Okay, so this thing is 5. So when you do this thing, 150 plus 200 is 350, minus 15 to 5 is 250, that will give you 100 joules. Okay, so it's option A that is correct. Okay, so in the next question, the momentum of a car of mass m increases from P1 to P2. What is the increase in the kinetic energy of the car? Okay, so you have to tell the kinetic energy of the car, but the options are given in the term of momentum. So first you need to understand what is the relation between the kinetic energy and the momentum. We know kinetic energy is equals to half mv square. Just to change this thing in form of the momentum, we know momentum is mv. Okay, so what I can do, I can multiply and I can divide this whole thing with m. So this thing will give me 1 by 2 m into m is m square, and v square is already there, so it can be written as mv whole square divided by m. So this thing is p square over 2m. Okay, so this is the kinetic energy. So you have to find the change in momentum. So change in kinetic energy. Kinetic energy is, change in kinetic energy is, kinetic energy, let's suppose final and initial. Final you can call 2, initial you can call 1. So it will be p2 square divided by 2m minus p1 square divided by 2m. 1 by 2m can be taken as common, so it will be p2 square minus p1 square. Okay, so it's option A. Okay, the most common mistake is most students choose option B. Why they choose option B? Because they don't understand that change in momentum square or square of the change in momentum are not the same. What I'm saying, p2 square minus p1 square is not equals to p2 minus p1 whole square. Okay, you don't have to take its change in this thing is like this. You first have to take the square, then you have to take the change, not in a way that you find the change first and take the square. This thing is right, this thing is wrong. Okay, so that you have to keep in mind. It is the change square of momentum, then you have to find the change. Okay, not do the other way around. Okay, so in the next question, question 20, what we have, a parachutist is falling at a constant terminal velocity. I like to highlight this thing. Which statement is not correct? Not correct. Okay, and the options are, this is from the conversion of energy. First we need to understand what is happening here. So if something is moving, object is moving downward, it's losing GP, obviously. In normal circumstances, this GP is converted into the kinetic energy, but velocity is constant. So you can say kinetic energy will be constant. Okay, that you need to keep in mind. So the loss of GP will not change into the kinetic energy. So where it will go? So this will go, this loss of GPE, you can say, let me make this thing, this loss of GPE will turn into the thermal energy. Which of the thing for in which form it will be converted? Thermal energy of the air particles, those are colliding, striking with the object and the object, because the surrounding and the object both will get the heat. So if we see the options, gravitational potential energy converted into the kinetic energy of the air, it's not only the air, but it's, now this is concept from the thermal energy. When the air is getting the thermal energy, it will gain the kinetic energy. It is true partially, but some of the thermal energy is gained by the object as well. So it's not the it's true, but we have to look at the wrong option, right? So it's true, this statement is true. In B, gravitational potential energy is converted into the kinetic energy of the parachutist. No, parachutists have a constant velocity, so that is the incorrect option. So we have to choose the incorrect, right? In C, gravitational potential energy is converted into the thermal energy. Yes, this was true, and this D is also. Okay, in question 21, the variation of length of the spring with the force applied to the spring is shown. What is the spring constant of the spring? Okay, so we know spring constant F is equals to kx, Hooke's law. So k is equals to f over x. X is the extension. Let's suppose we can take the value of f at this point. So it is 2.4. Okay, so this thing is the length, not the extension. This is the final length, this is the initial length. So this will be the extension, right? So it will be 0.6 minus 0.2, 2.4 divided by 0.4. That thing will give you 6. Okay, so it's option D. In the next question, the graph shows the variation with the force of extension of a wire, and the force is gradually increased to point Q. Now it's moving that way, and then gradually decreased to 0 at R. It's moved back to the original position. Which statement is correct? Okay, if you see the graph, the object started from this point, it's moved all the way there, and when you removed the load, the object moved back to the original position. So this thing is the elastic deformation, okay, because the object is coming back to the original shape when the load is removed. So what they're saying, A, along the line PQ, the wire obeys Hooke's law. No, wire is not obeying the Hooke's law, because for that they should be directly proportional. They should be a straight line. Along the RP, the spring constant is extension over force. No, it will be force over extension basically. And the wire has the elastic deformation at point Q. Yes, that is a true option. In the next option, a uniform metal wire of length L and diameter D has a spring constant K. What is the Young modulus of the metal? So basically we have to drive the relation for this thing in term of, if you see, you have in term of K and D. Okay, so basic relation for the Young modulus is stress over strain. Stress is force per unit area, strain is change in length over, let's call it L. So that will be F into L into X into A. Okay, so we don't have any option in term of A, and we don't have any option in term of F and X. So we know this thing, that this F and X from the Hooke's law, K is equals to F over X. So they can be written as K, and there is L and there is A. A is for the wire, it's a circular thing, so it's pi r square. Still we don't have any option in term of r, so we have to change r into d. We know r is d by 2, so it can be written as k l pi d by 2 whole square. So the 2 square will go up, it will be 4 kl divided by pi d square. It's option D. In the next question, an aircraft produces sound of frequency this, that is 30 hertz. Okay, and this is the frequency of the source. The speed of the sound is given, that is 330, so that is V. Aircraft is directly in front of stationary observer and travel in a straight line towards or away. It's not telling you that it's moving away or towards. The observer hears the sound from the aircraft at a frequency of 20 hertz. So this is the observed frequency. What is the speed and the direction of the aircraft? Okay, so you have to tell the speed of the aircraft. You have to tell Vs and the direction. Okay, if you compare Vs and V naught, Vs is greater than V naught. So whenever the frequency decrease, the head frequency is decrease, that observer is moving away from you. Okay, so aircraft moves away. By the way, this thing is from the Doppler's effect. Okay, so away, we have to choose between A and C. So the formula that we can use from the Doppler effect is F naught is equals to Fs into V divided by V plus Vs. Okay, this thing is important. Whenever the object is moving away, there come a positive sign, and whenever that thing is moving towards the observer, there comes a negative sign. So it's moving away, we will put negative sign. So you just have to put the values. You will get 20 is equals to 30 into 330 divided by 330 plus Vs. So you have to find Vs, so Vs will go there, 20 will go there, 330 plus Vs is equals to 330 into 330 divided by 20. So that thing will give you, if I calculate, it will be 495, 330 plus Vs. So Vs is equals to 165 meter per second. Okay, that is your final answer. So it's option C. In the next question, which statement about longitudinal and transversal wave motion for a progressive wave is correct? Okay, so in option A, all transversal longitudinal wave require a medium for propagation. No, mostly transversal waves are electromagnetic waves. They do not require any medium to pass, right? So that is wrong. All transversal wave travel at the same speed, but no, all transversal wave they travel at the same speed in the vacuum, but they can have a different speed in different mediums, right? In both transversal wave and longitudinal wave, a particle with a zero displacement has the maximum speed. Okay, yes, this is true, because at a zero displacement they will have the least potential energy and they will have the maximum kinetic energy that leads towards the maximum speed. Okay, next question, the diagram shows a progressive transverse wave on a stress string at one instant in time. One point of the string is labeled as X, they're talking about this point. Okay, and which point on the string is 270 out of the phase? Okay, so if we see, if we can label this thing, if you have a wave, you can say this thing 0, this thing 90, this is 180, this is 270, this thing can be 360 degree. So if you see A and B, they are at a 90 degree apart. They are 120, A and C, sorry, X and C, and X and D are 360 because it's again reached the same point from where it started. One wave is completed, it's 360. If you see this one, from this till this point, this is 180 and this is 90, so 180 plus 90 is 270, so it's option A. Okay. The next question, which wavelength of electromagnetic radiation is in free space could be green line? Okay, first that you need to keep in mind, the wavelength for the visible light. Okay, so lambda of visible light is 400 nanometer to 700 nanometer. Okay, so if you convert this thing, they all are in the standard form. So if you convert these values into the standard form, it will give you 4.0 10 raised to power minus 7 to 7.0 10 raised to power minus 7. When you look closely, you will get this option, the option C. Okay. By the way, for the green light, the wavelength is almost 550 nanometer. Okay, and nano is 10 raised to power minus 9 if you don't remember. Okay, which group contain only wave that can be polarized? So you have to keep in mind, transversal waves can only be polarized, longitudinal waves will not. We can't polarize the longitudinal waves, so this is not the option because sound is longitudinal. This is not the option, this is not the option. You are only left with the option B. B is correct. Okay, one wave has an amplitude of 2a, the other has an amplitude of a by 2. The waves are otherwise identical, they are traveling in opposite direction. What is the ratio of the maximum amplitude of combined wave and minimum? For maximum, we know they will be simply added up, so amplitude of first plus amplitude of second will be added. For minimum, the amplitude will be subtracted simply. So when you do this thing, this will give you 5a by 2. The lower thing will give you 3a by 2. This 2 and 2 cancel, a and a cancel, give you 5 by 3. It's option B you have. Okay. And the next question, light of wavelength 680 nanometer is incident normally on a diffraction grating of 450 lines per millimeter. What is the angle? You have to find theta, you have lambda of the second order maxima, n is equals to 2 in the diffraction pattern that is produced. Okay, so for the diffraction pattern, what formula we can use? It is d sine theta is equals to n lambda. Okay, so we have n, we have lambda, we don't have the d, so we have to find this thing. This d is basically 1 over n. What n is? N is number of lines per meter. Okay, 1 meter. So if you know there are 450 lines in 1 millimeter. Okay, so what I can do, I can use the ratio method. Let's do the ratio method here. If I write this thing as 450 lines in 1 millimeter, so how many lines will be in, how many millimeters are there in, we have to find in 1 meter, right? 1 meter is equals to 1000 millimeter in 1000 millimeter. So when you use this ratio method, what you can do, it will be x over 450 is equals to 1 over 1000. So x will be, sorry, it will be 1000 over 1. So x will be 450 into 1000, 450 and 3 zeros. Okay, this is the x number of lines. So you got the n. So n is this thing, and d will be equals to 1 by this whole value, that is 4500, one more zero. Okay, so this thing. So if you have to find the theta, what we can do, let me drag this thing on the side. Okay, so let's find the theta. Again, let's go back to the original equation. So d is equals to 145,000. Sine theta is equals to n is 2 and lambda is 680 nanometer. Nano is -9. So we have to find theta. So it will be sine theta is equals to 2 into 680 into 10 raised to power -9. Okay, so this thing will go there, 45000. So theta is equals to sine inverse of this whole value, whatever you get. Okay, let me calculate this thing. Okay, when you calculate this thing, you will get theta is equals to 38 degree. Okay, so it's option D we have, right? Let's move to the next question. I'm going to erase this thing because we are, okay, let's don't erase this. Let's keep this here. Okay, so in the next question, a hollow tube is closed at one end and open at the other. A stationary sound wave of the lowest possible frequency is given. Okay, so lowest possible frequency mean you have fundamental frequency is produced in the tube. The speed of the sound is given. What is the length of the tube? Okay, so if you see, you have speed, you have frequency, you can find the lambda. So v is equals to f lambda. Lambda is equals to v by f. V is 330, f is 820. So when you do the calculation, you will get 0.4 meter. Okay, what we have? We have a tube whose one end is closed. So as we know, when there are stationary waves, there will be a node, and at this point there should be a antinode at the open end of the tube. It will be like this. Okay, and if you remember this thing, this whole shape make 1 lambda. So we have this much portion, that is lambda by 4. So the length of the tube is equals to lambda by 4. Okay, so L is lambda by 4, that is 0. That will give you 0.1 meter. That can be equals to 10 centimeter. It's option A we have. Okay, so this is the diagram that we have drawn. This whole thing is basically the lambda, and we have taken the quarter of it, right? So this is the lambda by 4. That is the reason why this length is equals to lambda by 4. Okay, in the next question, which expression give the definition of resistance? Okay, so for the resistance, current divided by the potential, we know V is equals to IR, so R is equals to V over I. So that is not the case. Current multiply, no. Potential difference divided by the current, yes. Okay, so it's option C we have. In the next question, 33, that the graph shows the IV characteristic of electrical component, which is this. This is for the diode, because diode only allow the current to flow in one direction. So in one side, when the negative side, the current is 0, and on the positive side, it does suddenly increase. So that you have to keep in mind. This is for the semiconductor diode, option D you have. Okay, the next question. This is the most trickiest and difficult question of this paper. The diagram shows 6 identical resistors connected in series. In which branch of the circuit is the most power dissipated? Okay, so first you need to simplify this thing. Achha, what we know power is equals to voltage into current. Okay, so as we know, this whole thing, this whole thing have the same voltage and this thing have the same voltage. Okay, because they are all the P and R, they are both connected with the P and R terminals, and these terminals are directly attached with the battery. So this whole thing that I have highlighted there, whole thing have the same voltage, and this whole thing have the same voltage. Let's try to simplify this circuit first. If I simplify this thing, they all have the same resistance. So this is R, this is R, this is R. They all have the resistance R. If I simplify this thing, this will give me 2R, right? So this is, their combined resistance is 2R. And if I simplify these two, they are in parallel, their combined resistance will be R by 2. You can apply the relation 1 by R plus 1 by R. Okay, this will be, and then at the end take the reciprocal R by 2. So I can make this circuit in like this. It can be, there is point P, there is point R, P is attached with this thing, this is 2R, then there is a R. Okay, let's drag this thing here. Okay, because we have to tell the power dissipation between PQ or QR or RS or PS. Okay, so I'm going to simplify the resistances between these points. Okay, so between this point is basically the Q. Okay, so for the lower part it is, I can make this is R, there is point S, and again there is R by 2, and there the circuit is completed. Okay, and they are attached with the battery. Okay, so let's discuss the current first. If you see this above thing, this is the one possible path for the current, and there is this one possible path for the current. When the current will come at this point, it will split into two parts. Let's suppose I is coming here, let's call it I1, let's call it I2. It will be split into two parts. The current will go more where the resistance is less. So this total resistance, if you see, this total resistance is 3R, and this total resistance is 3R by 2. So there will be more current, you can say. So we know I2 will be greater than I1, and we know this thing, the total voltage among both of them, this whole thing have V and this whole thing have V. So we can just ignore this thing because this have a less current. So let's deal with this thing. This will have a more current. So this thing is having a more current. Now we have to choose between PS and SR. Now we have to look at which one will have the more voltage. So they both are in series. Okay, and they have total voltage. You can plot them like this. This is R, this is R by 2, and they have total voltage V. So the one with the higher resistance will have the high voltage, so this will have more V, already have high current, so this will have maximum power. Okay, so this thing will have maximum power, it is PS. It's option D. Okay, let's move to the next question. The diagram shows a circuit containing a thermistor, a fixed resistor and a battery. The graph shows the IV characteristic of both the components. The battery has the EMF of 12 watts and negligible internal resistance. The current in the what is the current in the fixed resistor? What is the condition? You have a graph in which voltage is changing and they have shown you the response of the current. You have to tell what will be the current in the resistor when the voltage is 12. Okay, so you have the different options. We have to check them one by one. Okay, there's no other alternative way to do this thing. Let's suppose if we try this one, when the current is 0.36, then what will happen? So we have, if you see, we have, these are 10 boxes, so I can say 10 boxes equals to 0.4 milliampere. So one box will show me 0.04 milliampere. Okay, so if this thing is 0.4 minus 0.04, this thing will be 0.36. okay, so I have to look at the, okay, this will be the voltage here at this point. This is for the fixed resistor. Okay, so this voltage is 5.4, and at this point this voltage is 6.6. so 5.4 plus 6.6 will give me 12 watts. Perfect. This was the given condition, so this is the right option. Okay, you can check other options as well, like 0.4. If 0.4 is there, you will see the voltage is somehow 6, and this voltage for the thermistor it is 6.5 something. So 6 plus 6.5 will be greater than 12. So the total voltage among the components will not be greater than the provided EMF. Okay, this is the basic rule, so it will not be the option. You can check other options as well, they're all incorrect. Okay, this is the correct option, option A. And next question, two resistors of resistance R1 and R2, they are connected in parallel. You have to tell the relation for it. You have to just keep in mind, whenever the resistors are connected in parallel, their total resistance will be product of their individual resistance divided by sum of their resistances. Okay, simply. So it is option B you have. Okay, so, and the next question, a cell is connected in a series with an ammeter and a variable resistor. A voltmeter is used to measure the potential difference across the resistor. The resistance of the variable resistor varied with the potential difference across the load. What you have to do, what is the internal resistance of the cell? Okay, you have to keep in mind, you can write down this thing whenever the terminal potential difference is on y-axis and current is on x-axis, gradient will be equals to minus R. What is minus R? Internal resistance. Okay, so you just have to find the gradient of that thing and you have to equate that thing equal to minus R. So let's take two values. Let's call this one, this is x1, y1, and these points are 0 and 1.6. and you can take any other point. Let's take this one, call this x2, y2. x2 is 40 and y2 is 0.8. so when we take the gradient, y2 minus y1, x2 minus x1, y2 minus y1 is 0.8 minus 1.6 divided by 40 minus 0, and if you see there is a milliampere. Okay, so that is 10 power minus 3. This will give you minus 20. Now you have to equate gradient equals to minus R. So minus 20 is equals to minus R, so R is equals to 20 ohms. Okay, so option C is correct. The next question, which list contain only the fundamental particles? So in A option we have neutron and electron. They are not the fundamental particles. Same as electron is not fundamental particle. Positron, quark, hadrons, protons. Protons are not the fundamental particles. Quark, positron, neutrinos, and lepton. They're all the fundamental. So D is the right option. Okay. The next question, which statement explain why alpha particle have the discrete energies but beta particle have the continuous range of the energies? Okay. Beta particle have much smaller mass than the alpha particle, which means beta particle can emit with a larger range of no. Alpha particles experience repulsion from the no. Only beta particles are emitted with other leptons. Yes, this is the right option. They are emitted with other leptons, and these leptons are called neutrinos or antineutrinos, right? So it depends, it's beta positive or beta negative emission. The next question, a hadron consists of antiquarks that are all identical. What is the possible value in terms of the elementary charge?